What up, Algebra 2 students? Mr. Mester coming at you, going over the review, telling my students, okay, step one, always, even before you do anything on the test, is everything on one side. Step two, did you factor out a greatest common factor? Before I'm going to do any of these problems, I'm just going to peruse through and see is it in a quadratic, either equal to y or equal to 0 form, or is it not? Okay. And then if it is a quadratic, is there a number that I could factor out, a greatest common factor that I could factor out? I look at the first page and we're all good. Everything's fine. Once I start looking at the other pages, though, we're going to start to see some pop up. Second page, okay, there's no number that I can pull out of this, this, and this, and everything's on one side good. That's set up. This, good, good, good. Set up for success, we're good. Here, 3, 12, and 14, I can't divide those by the same number. That's good. Everything's on one side. Boom. This guy right here. I have an 11x on one side. Yo, I could set this up right now, not even doing the problem, but just for the future, I got to move that 11x to the other side. We use algebra to move it, okay? We don't just move it over. We subtract 11x from both sides, just like you would if you were to solve an equation. So now, and I'm going to put things in order because that'll help me. I have 12x squared minus 11x minus 5 equals 0. Leaving that, we'll come back to it. Oh, look at this one. It's got a 6 on this side. Step one, is everything on one side? No. We haven't seen anything where we're factoring out a greatest common factor yet, but we're going to see it in a second. Okay, I subtracted 6 from both sides. When I subtract 6 from the right side, it's a 0 left over. That's why I have a 0 right here. So where is it? There you go. That's why I got that 0 right there. 6 minus 6 is 0. Did the same thing here. 11x minus 11x, that's 0. Okay? Now, is everything on one side? Yes. Can I factor out a greatest common factor? Can I divide everything by a number? Yes. Every single one of these numbers you can divide by 3. If you tried to do the box method for this quadratic without the greatest common factor factored out, it gets real messy and it doesn't work out really nicely. So before you do any problems, guys, on your test, you can do this. Make sure you check, and if you need your calculator, do some work here, like 66 divided by 3 if you need to check. See, it's 22. Great. That's how I got 22x. I divided 66x by 3. 21 divided by 3 is 7. Now, we're going to just leave this 3 here. We can essentially ignore it, okay? But just leave it there. We're going to ignore it. I don't want to remove it. I don't want to divide by 3 and then it goes away. Sometimes we'll create bad habits in the future when people think you can divide by other things, but you can't. So anyways, just leave it and we're going to ignore it. Again, is everything on one side? Nope. To get rid of this, to move this negative 5x, I'd have to add 5x. Okay. Can I divide all of these numbers by a number? No. I can't divide everything by 2 or 3 or 4 or anything, so I'm done. Here, everything's on one side, but I can divide all of these by the number 3. Factoring out a greatest common factor. Incredibly crucial. Make sure you do it correctly. Use your calculator if you need to do it. And 27 divided by 3, 6 divided by 3. All right, good. We'll come back to that. It's the same thing for our special products. Is everything on one side? Yes. Can I divide a number out? Can I divide both of these numbers by 2? Nope. Can I divide both of these numbers by something? I actually think I can, but I don't know if I want to. I know I can do that. I don't think I'll be able to divide this by 3. Good. All right. So I'm just going to leave it. All right. This guy, though. 20 and 45. I can divide everything by 5. Now, your test is not going to be this long, so this won't take as long of a process to do, uh, but it's going to help you tremendously. Okay, if you just spend a little bit of time making sure like things are set up for success. All right, we'll come back to these and we'll double check along the way. All right, now what are we doing in this unit? We're finding zeros. We're finding x-intercepts. Beautiful. First lesson shows us a visual representation of finding x-intercepts. We got x squared minus 3x plus 2. My students will be using my Desmos link for the first page of their test. Then they're going to put away the laptop and not worry about it. Other students in other classes will be using their graphing calculators to graph. My computer just froze. It's coming back. I don't know if this is actually recording or if it's going to have a lot of like blips. Man, Desmos is like breaking the system. All right, we're back. That was crazy. So my students will be able to just type in, looking on their test, x squared minus 3x plus 2. Don't delete the whole thing or else you're going to like not be able to type it in. Okay. We are looking for when y equals 0, when our equation equals 0, when y is 0. My students do not have to fill out the entire table. Uh, Other students in other classes, your teacher might have asked you to fill out the table, so you're going to do it. All I care about is the location of the solutions and then a nice little sketch. Okay, so the location of the solutions you can click on, you can see they're at 1, 0, and 2, 0. My students, all I want you to do is sketch this 1, 0, this 2, 0, sketch the graph, and x equals 1, x equals 2. I don't care that it's the point 1, 0, and 2, 0. We are finding the solution to this equation where my quadratic, my U shape, has a y coordinate of 0. Okay, if you want to put the points here, I'm sure other teachers will require you to do that. My students, I just care about the solutions. X is 1 and x is 2. All right, let's go through and do the other ones. If you have another teacher, you're expected to use a calculator. So this is how you use your calculator. X squared plus 8x plus 16. You can visually see it when you graph. You can then go into your table. Table's usually set up for whole numbers, so it's good. You can move your table around to see when your y is 0, not when your x is 0. Like, you can go back into the graph and see that. Okay, I only have 1, 0 at -4. This is one of those situations where our vertex is located on the x-axis. So we have -4, 0. My solution is -4. If your teacher asks you to fill out the table, fill out the table. Okay. I'm going to do my way the rest of the way. So just using Desmos and just like clicking and seeing. So we're visually seeing our whole goal of this unit is finding zeros. Zeros of quadratic, some are going to be cubics. Here we go, x squared minus 8x plus 20. We notice there is no 0. Okay, it's above the x-axis. We got this here, boom, we go up. Since we have no y equals zeros, no uh, x-intercepts, no roots, we have no solutions. We're going to call these no real solutions. Why can't we just say no solutions, Mr. Mester? Because we're going to talk about in next unit what an imaginary solution is and how we can have actually imaginary solutions. We'll talk about imaginary numbers. So that'll be fun. Look forward to that. -14x plus 48. Okay, my students, boom, 6 and 8. 6 and 8, wherever that is. I'm not even going to count. I'm not going to spend much time on this. You guys know how to do this. If we're wasting time on this, then that's silly. We got other stuff that involves more attention. Negative x squared plus 2x minus 5. Negative, I'll put in front, x squared plus 2x minus 5. Oh, I don't see any solutions. We are no real solutions. There are no points on the graph where the y coordinate is 0. Looks like that. Boom, that's all I care about. X squared minus 10x plus 25. This is going to be 1. I know it. Let's say you deleted the whole thing. What do? X. Use the little caret symbol. That's above the 6. So shift 6 on your computer. If you are using your calculator, you could just type in x squared. Okay. So F shift 6, there's the square. What's the equation? Minus 10x plus 25. Minus 10x plus 25. All right, and boom, we see 1 point where the y coordinate is 0. This is at 5, 0. Don't put the point down. We are looking at when y is 0. This is going to be at 5, 0. We have one solution. Our vertex is on the x-axis. There's one x-intercept. X equals 5. 5, 0. Okay? Make sure you pay attention to your teachers and what they expect of you. So if they want a bunch of points, provide them the points that they want. If they want the vertex, all right, give them the vertex. I don't care. All right. Now we get into day 2. Day 2 is probably the trickiest day. Day 3 is very much just like a use this formula, you're going to be okay. This is what I teach my students. I'm going to show both ways for other students. Okay. I say, yo, guys, is A 1 in our quadratic? Okay. If A is 1, we can actually just do the x and skip the box. I'll show you that in a second. If A is not 1, or if you're not used to things and you've always done the box, use the box. Okay. Now, what is the purpose of this? Well, we don't have our calculators. We can't graph anymore. If you're just going to be graphing on your graphing calculator and finding the solutions, you're going to get 0 credit, maybe a very small amount of credit for just putting down X. You need to show your work for how we're finding these solutions without the use of a calculator and graphing capabilities. So my students will be just like, boom, like shutting down their computers. And if they're using a graphing calculator, I'm giving them like nothing for just a solution. Okay. So what is our purpose? Well, we remember from last unit the whole concept of an intercept form. X plus P, X, it's actually X minus P and X minus Q. This is intercept form. And we know that this actually, has a quadratic. This looks like a quadratic. We know that x equals p and x equals q are our intercepts. Why? Because if I plug in p, you get 0. If I plug in q, you get 0. Okay? We are going to take this standard form and try to turn it into intercept form. How are we going to do it? Well, like if you understand distribution, like x plus 6 and x plus 4. Let me just show you really quickly. This is not like how you do this. I'm just showing you this. If I multiplied x plus 6 and x plus 4 together, I get x squared, I get 6x, I get 4x, and I get 24. And I get x squared plus 10x plus 24. Okay? Our goal is to take that, but then turn it into this. Because when we turn it into this, we can easily see what our intercepts are. It's going to be negative 6 and negative 4. Okay? So the way we back things out is we end up playing a little number puzzle. Okay? We're going to do a little bit of a number puzzle to help us back out this distribution. I'm going to try to fill in the boxes if I need to. And then I will factor out, I will backwards distribute or factor. so that I can figure out, oh, this is actually x plus 6 and x plus 4. Boom, I got x plus 6, x plus 4. I've just turned standard form into intercept form. X equals negative 6, x equals negative 4, my solutions, because those are my intercepts. All right, how do we do that? Boom. A times C and B. Okay. It's just like the way that we figured out backwards distribution, like 6 times 4, 24. We're going to try to find two numbers here and here that multiply to get 24, which is A times C. Okay. What else do we notice? Oh, 6x and 4x. When I distribute this, I got 6x and 4x. They add to get the middle. So we got this concept of our B, 10. We're going to find two numbers that multiply to get A times C and add to get B. For my students, I put a dot and a plus, just above the AC and below the B, just so I remember that. If you want to, up here for this box, just put a dot and a plus. Okay, and this is just because we understand distribution, why are we doing this number puzzle. Okay, now the easy way to do this, guys, is to list off your factors of your big number, the A times C number. It's not necessarily the bigger number. It's just like that top number is the most important, 24, the A times C. Let's focus on that, okay? And you listing off the factors just by dividing it by 1, 2, 3, 4 until we get like all the possible combinations of numbers that get 24 will help you, because then you can think about like, okay, which pair can I manipulate in some way so that they will add to get 10 and they multiply to get 24. Well, we just saw earlier it's 6 and 4. Okay, 6 and 4. Okay, this is A, this is B, this is C. Sorry for skipping that. All right. Now, I tell my students, yo, guys, after doing a couple of these, you don't need to do the box. Okay? If you think about x plus 6 and x plus 4 and distributing things, it works out perfectly that you get x squared plus 10x plus 24. That's what I got. So I tell my students, yo, if A is 1, we can skip the box. We go straight to the factored form, and then we have our solutions. Like after noticing this, after doing the box in class a couple times, we skip the box when A is 1. Okay. Now let's say we don't skip the box. You've done this every single time. This is what we do. This will always be ax squared. Ax squared will always go in the top corner. C will always go in the bottom corner. So this is x squared and this is 24. The whole purpose is to split up this middle term, because when we distribute, we got the plus 6x and plus 4x. And we move this number that we figured out, we move it into the box. And these are amounts of x's. So 6x, 4x go here in here. Doesn't matter which way you put it, it'll work out. And then what we do is we kind of undo multiplication. We divide, which is like factoring. So reverse distribution, factoring. And you try to figure out what is the biggest thing that both of them share. What is the greatest common factor of these two terms? X. Of these two terms, 4. Then we go sideways. What's the biggest factor of these? What do they share? They share an X. What is the biggest thing that these two, 6x and 24, share? A 6. And checking signs, making sure they're good. Boom. You get that x plus 4, x plus 6. This is unnecessary to do when A is 1. When A is 1, you'll always have x times x, and then your number and your other number next to that. Okay? If your teacher requires you to use the box, use the box. Okay? So let's do another one where A is 1. 1, negative 6, 9. A times C goes on the top. A times C goes on the top. That's 9. Now notice A is 1. We're trying to figure out two numbers that multiply to get that. And then they add to get B. Put a B and a plus. Your only options, again, the most important number is this top number. It's like limiting the amount of selections that we have, are 9 and 1 and 3 and 3. Okay? But I need two numbers to add to get -6 and multiply to get +9. This is why I'm going to use these threes, but they have to be negatives. -3x and -3x. Add to get -6x. -3 times -3 will multiply to get 9. Is a 1? Well, I could go straight to x minus 3 and x minus 3. How do I know that's going to work? Well, watch. Like x squared, -3x, -3x, +9. Maybe you like get around the whole Mr. Messner says I don't have to show the box. Like this is me showing the box without actually doing the process of the box. Like if a is 1, the box is not needed. We just get x minus 3 and x minus 3. That's x minus 3 squared, but whatever. The key is like, and a lot of students do this, they write x equals 3 and x equals 3 are our solutions. They're our intercepts. Well, isn't this the same number? So isn't this at one location? This is a situation like here where you have one intercept, one location, 1, 0. You're not going to write it down twice. It occurs twice. We'll talk about multiplicities in the future, but just leave that x equals 3. Okay? Now, let's say you don't like that whole skipping the box. Let's say you like to go every single step along the way. What you would do is the x squared goes here, the -9 goes there. You fill in your other boxes with amounts of x's. This is the whole number puzzle that helps us figure this out. And then we back out. So what do x squared and 3x share? An x. 3x and 9. Let's say you say 3. Like they both share 3. Let's say you say that. Let's go the other way. X squared and 3x and x. -3x and 9. Let's see you say +3. Because they do share a +3. The key, guys, is when you're backing things out, make sure if you filled in the box, it works. Like, will you get x squared minus 6x plus 9 if you did x plus 3 and x plus 3? Would you be able to distribute these and get what you're looking for? And the answer is no, not if these are +3s. I need to make sure we have the correct signs. -3, -3. It's not because these numbers are negative. Sometimes it will be like one will be positive, one will be negative. It's just because that's how it works. So that I get x squared minus 6x plus 9. That is x minus 3 times x minus 3. Okay? All right. Now we have a situation where a box is necessary. A doesn't equal 1, you got to use the box. Okay? We got to know what A, B, and C are. Okay? We got to be neat and orderly. You got to ask your teacher if you ever get stuck. There's going to be one or two where they're not going to be factorable. You'll be able to check to see if there's no solutions if you like graph using a graphing calculator. But like, it's not something that I recommend doing. It's like let's just ask. If you're stuck on a number puzzle, ask and we'll help you. Okay. We got to do A times C. Let's use our calculator here. 3 times 14. Quit. 3 times 14 is 42. This is our important number. This is going to give us our factors. Two numbers that multiply to get that. B is -12. That's B. Looking for two numbers that add to get that. Okay. AX goes in the top corner. C goes in the bottom corner. This makes sense if you understand distribution. I hope your teacher had you practice distributing using the box. That way you know where the box comes from. Okay. I always like to check by distributing and making sure that it's all good. All right. Now we got to play the game. All right, 42. What are some options to create 42 in terms of products? 42 and 1, 21 and 2. I'm just going to use my calculator and start dividing. 42 divided by 2. Okay, 42 divided by 3. All right, 14 and 3. 42 divided by 4. Nope. I know it doesn't divide by 6, but I know it does divide by 7. I mean, 6 and 7. I know it doesn't divide by 5, but it does divide by 6. So 7 and 6. All right. Great. This is it, guys. There are not two numbers that multiply to get 42 and add to get negative 12. I'm thinking about like, it's either both of them are positive or they both really have to be negative. So this should be like a negative and a negative, but those had to get 13, but it's a 12. I'm thinking about this being a negative and this being a negative. Well, that gets negative 17, so that doesn't work. So none. You cannot factor this, which means there are no real solutions. Let's say you have your calculator. I don't know if your teachers are allowing you to do this. Like I don't use the graphing calculator in my class. I use Desmos and I use the yellow ones. But like if you graph this, what are we going to see? It's not going to touch the x-axis. This is a way to kind of check that it's not factorable if your teacher allows you to use a graphing calculator. My students, you're going to ask me, like, if you're using a yellow calculator, you're going to ask me, you're like, hey, can I figure out this number puzzle? And I'm like, well, list off 3 factors. Did you try this? Yeah, I tried this. Did I try this? Yeah, I tried this. Okay, none of them worked, right? It's not factorable. Okay, but don't just like assume it doesn't work. Sometimes like they'll be tricky on you. So there you go. All right, we back to this one. Remember this one? Everything's got to be on one side. We already put that work in. We already did that. So we're ready to go. A is not 1. A is not 1. We got to use the box. We got to fill it out correctly. We got to back up, make sure everything's good. We got 12. We got negative 11. We got negative 5. Great. Let's multiply A and C. Those are the two numbers we're looking at that will multiply 12 times negative 5. And I get negative 60. Great. That's a nice rectangle. 60 is a lot of options to get 60. And then B is negative 11. We're looking at two numbers that multiply to get A times C and add to get B. If you want to do that right now, great. I'm going to go ahead and fill in some of the spots in my box, 12x squared and negative 5. Now I got to figure out how the combination of my x's to make negative 11x. We're backwards distributing here. Okay, so two numbers that multiply to get negative 16, add to get negative 11. Well, we got negative 60, or let's just go with the positive. 60 and 1, yeah, that's not going to be it. 30 and 2, yeah, that's not going to be it. 20 and 3, that's not going to be it. One of them's going to be positive, one's going to be negative, so we got to keep an eye on that. Can 60 divided by 4? Yep, 15 and 4. Ooh, hold the phone. Stop the presses. Don't go any further. I can combine 15 and 4 to make 11. But how? Well, if this is negative and this is positive, I multiply to get negative 60 and I add to get 4. Guys, if you are just watching this video and copying down everything, just stop and do this problem. Okay, do this problem. And then come back and watch. Pause before we do problems, then come back. All right, so we're going to fill in our box. It doesn't matter which order you put things in, but we have to use the box here. A is not 1. We have to use the box. Many students think we can skip the box and just say A minus 15 and X plus 4. No, you are wrong. If you try to multiply X minus 15 and X plus 4 together, you're not going to get 12X squared minus 11X minus 5. You're not going to get the solutions. You must use the box when A is not 1. Okay? You must figure out all their shared things. 4X and negative 5. doesn't look like anything, so maybe it's 1. Maybe it's -1. I don't know. We'll figure that out. We're just going to put 1 for right now. 12x squared and -15x. I can divide both of those by 3 and x. Maybe it's -3x. I don't know. I like to keep the top left ones always positive. Okay, you can change them, but I like to keep these positive and just change these numbers as positive or negative. Okay, now we go to the side. 12x squared and 4x. Well, like 4 goes into both, and they both have an x. 3x and 4x. Does that multiply to get 12x squared? Yes. 4x and +1. Does that multiply to get 4x? Yes. These are the things we're checking here. Now, -15x, -5. Seeing both of those negatives, it's really kind of making me think that I need to have a -5. Let's say you put a +5 here. Well, it doesn't work. 3x times 5 is not -15. 5 times 1 is not -5. That's why I put a -5. Okay? Now I double check. Like, imagine this wasn't here and I asked you, hey guys, can you multiply 3x plus 1 and 4x minus 5 for me and tell me what this is in standard form? Well, you'd say 12x squared, 4x, -15x. This is multiplying -5. -15x and 4x combined to be -11x. Boom. I multiply these together. I get this. I've gone backwards. I get this. Great. But we're not done yet. What are our solutions? This is in intercept form, but it's technically different. It's not just x minus p and x minus q. I got 3x plus 1. I got 4x minus 5. Many of my students have been saying, oh, it's -1. Oh, it's got to be +5 because it's going to be the opposite of this number. It's not that. To figure this out, we got to think like, what makes this piece 0? 0 is the key because 0 times anything is 0. So it's not -1, but it's -1 divided by 3. It's like I'm solving this equation one step at a time to get x equals -1 over 3. That's the location of my intercept. You're not going to see that on your graphing calculator unless you know tricks on your graphing calculator. You'd see that on Desmos, but I'm not going to let you use Desmos after we do the graphing part, my students. Add 5. Add 5. 4x equals 5. Divide by 4. Divide by 4. X equals 5/4. X equals -1/3. X equals 5/4. Those are our two solutions. Okay? There are more ones where A does not equal 1 than A equals 1 on your test. We need to practice these more. Okay? Then just assume, oh, I know how to do this, so I'm going to just do this all the time. All right, we've done a little bit of work earlier, moving everything onto one side. We can write down what A, B, and C are. We can write down in our little graphic organizer, A times C, looking for two numbers that multiply to get that. That's -36. B, looking for two numbers that add to get that. This number up top, more important number, let's write down the factors of 36. 36 and 1. Yeah, that's not going to do it. 36 divided by 2. Oh, you don't know? Use your calculator. 36 divided by 2. It's going to be 18. Can I combine those to get 5? No. Let's do 36 divided by 3. It's going to be 12. Can I combine those to get 5? No. Let's do 36 divided by 4. 9. Beep. Stop. 9 and 4 can combine to make 5. 9 minus 4 combines to get 5. +9, -4. Does this work? +9 minus 4 adds to get 5. +9 minus 4. Multiply to get A times C. Boom. This is us undoing distribution. This is us going backwards to turn standard form into intercept form. All right, but I can't just skip the box because A is not 1. I got to do all this stuff. That's top left, ax squared. Bottom right, c. Your solutions to the number puzzle in any order, there and there. These are amounts of x's. Now, divide out the greatest common factor for these terms. 6x squared, 9x, 3 goes into both, and an x. Negative 4x and negative 6. I'm feeling like it's got to be negative 2. Maybe you put positive 2, but we'll have to check. 6x squared, negative 4x. 2 and x. Keep these guys in the top corners positive. It's these that can be positive or negative. Negative 9x, negative 6. What do they share? A 3. Is it positive? It's negative? I don't know. Like, one's positive, one's negative, so I'm not sure. So, ready, guys? Pretend this stuff isn't here. Do you make 6x squared plus 5x minus 6 if you multiplied 3x minus 2 and 2x plus 3? Let's see. Distributing two things to two things, we just distribute everything. 3x and 2x, 6x squared. Negative 2 and 2x, negative 4x. 3x and 3, 9x. 3 and negative 2, negative 6. We're adding all these terms together. The 9x and the negative 4x make a positive 5x. I've checked. I did it correctly. If you don't pull out the greatest common factor, by thinking and checking, by thinking about distribution and checking, you could be like, oh, I made a mistake somewhere. Maybe let's go back and fix this. Maybe you put a 1 out here. If you put a 1 out here, well, it's like 2x and 1. Oh, nope, that doesn't work. I should be getting negative 4x. So always check by thinking about distribution and multiplication. All right, so 3x minus 2, 2x plus 3. Now I'm in intercept form, but again, I have to do a little bit more work to find the solutions. Add 2, divide by 3, x is 2/3. Subtract 3, divide by 2. Many of you have done this enough over the course of doing your homeworks that you don't have to show this work. You're kind of thinking, oh, this has to be positive 2, but I'm multiplying by 3, which means it's got to be 2/3. Oh, this needs to be negative 3 because negative 3 plus 3 is 0. And for this to be negative 3, it needs to be negative 3 halves. Some of you have kind of figured that out. If you haven't, please, please, please do all the work, okay? These are my two solutions. Everything's on one side. A greatest common factor is factored out. Guys, this is so important. Is everything on one side? Did you factor out a greatest common factor? If you don't do that, it's going to be really tough and you're going to be able to do it. And then you're going to get all frustrated because you're like, what happened? I don't know what I'm doing. It's like, no, you just forgot 2 key steps. You can essentially ignore this 3. I'm going to write out the factored form with the 3 in it, but nothing comes from that 3. You can essentially divide everything by 3 and the 3 goes away, but I don't want us to do that, okay? So let's just pretend it's not there. Let's think of this as being A, this being B, this as being C. All right? So 3, 22, 7. A times C, 21. B, 22. 21 and 1. Right off the bat, I know add to get 22. So I'm done here. These are my little question marks. This is what's helping me fill in the box. 3x squared, that's the ax squared that goes in the top corner. C goes in the bottom corner. Amounts of x's go in the other two boxes in whatever order you want. Factor out, backwards distribute, a 7, an x. If I'm going too fast, you can pause. A 3x, a 1. Double check, pretend that this isn't filled out. If you distributed x plus 7 and 3x plus 1, does it fill out the box correctly? 3x squared, 21x, 1x, 7. Yes. We ignored this 3. That's fine. Technically, you still have that 3 there, but it's not going to give us any solution. It's not an x, like 0 isn't a solution. So if you want to just ignore it and be like, yo, I don't care about it, I just divided it out at the beginning, honestly, it's fine. For the future, though, we have to worry about things we factor out. This is a nice intercept form. We get x equals -7 to make a 0. Here, we need a -1. Divide that by 3, -1/3. Not sure how to do that. Solve this equation. Two intercepts, x equals -7 and x equals -1/3. All right, the last two I'm going to blow through. Blown through this. Pause if pause to do it. Okay, pause to do it by yourself. These are good box questions. One of them I have a greatest common factor factored out. One of them I don't. Maybe one of them doesn't work. Maybe one of them does. So pause, do them, and then look at the answers. All right, here we go. Mr. Messner going quickly. 2, 5, 6. 12 is A times C dot. 5 is B. Add. I don't think this is going to work out. 12 and 1 doesn't. 6 and 2 doesn't. 4 and 3 does not. So does not work, does not work. There are no real solutions. Those of you who use graphing calculators, you probably should graph to make sure that that works. What do I mean by that works? You probably should graph to make sure to check that you don't cross the x-axis anywhere. There you go. My students who don't have it, you're going to just check with me. You're like, I'm pretty sure this doesn't work. And I'm going to be like, you are correct. I don't want us to mess up because of a number puzzle game. All right, last one here. Ignore the 3. Ignore the 3. Pretend it's not there. But we've done this work to get rid of it. It's important. A times C dot B plus, yeah, dude, 10 and 1. 10 and 1 can get 9. It needs to be -9, though. -10, +1. There's my number puzzle game. That's amount of x's. A x squared goes here. C goes here. The amounts of x's, wherever you want to put them. It'll work out. Start pulling out stuff. I really feel like a -2 needs to be pulled out. Maybe you don't. Maybe you put a +2. Just double check at the end. Here, just seeing an x here. Here I see 5 and an x. Here I don't see anything. So it's just a 1. Okay, like double check. 5x times x, 5x squared. 5x -2, -10x. X and 1, 1x. 1 times -2, -2. We win. Two solutions. One at +2. That's an intercept form, like +2. The other one, when 5x plus 1 equals 0, that's going to be -1/5. If you've done it enough, you know how I'm getting this. Subtract 1, subtract 1. Divide by 5, divide by 5. X equals -1/5. Okay. All right. Yo, difference of squares, difference of cubes. Identify if you have a square or if you have a cube. Think about like what can be squared to get your term. I'll call that my first. Difference of squares are easy. So it's going to be your first plus your second, your first minus your second. That's the whole m's and n's. Sometimes m's and n's and numbers are messed up. Yo, cubes. I'm going to write your cube rule. Cubes. Here's what you're going to do. 2 sets of parentheses, but they're not the same size. One's bigger than the other. Here's what goes in the parentheses. Your first That's the whole M. Your second. Your first squared. My students have been messing up on the first squared. So I'm just going to say, yo, your first times your first. That goes here. In the middle, your first times your second. And at the end, your second times your second. Okay? That's the second squared. We then use SOAP to fill out the signs. You don't have to worry about the signs for the difference of squares because it's always a plus and a minus in between the first and the second. The cubes are different. S stands for same. O stands for opposite. AP stands for always. Positive. Okay? Now, we're going to get a factored form, but we're only going to get like one real solution from the factored form. This has been messing up all my students for the cubes. They're like, why do we do this if I can just figure out, like, pretty much by looking at this, what my answer is? It's just something that you're required to do. And when we find imaginary solutions, we're going to need the factored form so that we can find the one real and the two imaginary solutions. So this is what we just have to do. Okay, guys? So look at what you have. What do you have? Well, I see x squared, so I'm talking about squares, squares, squares. Okay? What number times itself once gives us 36? 6. And then x times itself gives us x squared. What number times itself gives us 1? 1. This is what I consider my first. This is my second. First plus second. First minus second. This is correct. Now watch this, guys. If you box this, you can make sure that this is correct. A lot of students don't do this because it's like, oh, well, it takes too long. But like, I'm going to show you. 6x times 6x, 36x squared, good. 6x and 1, positive 6x. 6x and negative 1, negative 6x. Negative 1 and positive 1, negative 1. The 6x's, when you add them together, go away. 36x squared minus 1. Okay? Now, what are the solutions we get? The real solutions we get, subtract 1 divided by 6. I get negative 1/6. Add 1 divided by 6. I get positive 1/6. For those students that are still like, what? Where did that come from? We're just trying to figure out when the terms equal 0. I'm solving this simple equation. Add 1, divide by 6. I got negative 1/6, positive 1/6. Okay, now cubes. Identify like the first and your second. Since it's cubed, we're talking about what are the numbers times itself that give us numbers times itself 3 times to give us these values. Like x cubed, like x times itself. X times x times x is x cubed. Okay, so that's how I identify my first. What number times itself 3 times gives us 64? Guys, don't worry about this sign right now. Don't worry about this sign. What number times itself gives us 64? Well, we can start writing down a list of like the perfect cubes and the perfect squares if you want to. Like 1 or 2 cubed, or 2 times 2 times 2, whatever you want to do, is 8. 3 cubed, 27. 4. You can like have a running number going here. 4 cubed is 64. Just start writing this down. Okay. So what I call my second, this is the whole n, is the number 4, who like 4 times 4 times 4 is 64. Okay. You got that? Now, watch what I do here. First, second. First, second, second, second. Just going to move that up there. I'm going to show you how I fill it in. First, second. Don't worry about the sign. Okay? Always keep this as a positive thing. Okay. First times first. This is the whole m squared. First times first. X times x is x squared. That's the whole m squared. That's the first squared. First times second, 4x. Second times second, 16. That's the whole n squared. Okay? Now, we pay attention to the sign. See that negative? Same sign, opposite sign, always positive. Now, for this unit, all I care about is the solution that comes from there, that kind of intercept form, this x equals 4. For your tests, we care that you have the correct factored form. We care that you have this. For future units, we will have to figure out imaginary solutions from that. We will not be able to find any factored. This will never be factorable, guys. It will never be factorable. However, there are imaginary solutions that come from it, which we will have to find in the future. So this is why we're doing it. You are required to show this because it's necessary for the future. Right now, for the solution, we care about is just that 4. Okay? All right, let's do that again. Ready? X times itself 3 times. X cubed. That's my first. My second term, 216, well, like keep your running tally going. I think it's 6. 6 times 6 times 6, or 6 cubed, is 216. Okay, keep your running tally going and pay attention. Okay. 2 sets of parentheses. Your first, your second, your first times your first, your first times your second times your second. That's how I do it. I think it's just easier for you to understand. It's the whole x squared 36. First, second, first, second, second. Again, it's just a rule for you guys to remember. Soap, same sign. What's the sign? Plus. Opposite sign. Always positive. Always positive. The only solution from cubics, sums or difference of cubes, are going to be from this factor. This isn't a quadratic even. This is a cubic. Like we've been solving quadratic equations. Like these don't look like quadratics, but whatever. It's just still like factoring. It's still seeing kind of like an intercept form. And in the future, we will be trying to solve this and finding imaginary solutions. The only solution I get is from here. When does this equal 0? -6. You need the factored form. You need the correct solution to get full credit. What are these? Squares. First, second. Ignore that. First, second. Smaller ones with a plus and a minus. You always know it's going to be a plus and a minus. You just got to figure out 2x times 2x is 4x squared. There's my first. 7 times 7 is 49. Notice I'm not looking at cubes, I'm looking at squares. Okay, so perfect squares like 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. This is different from cubes. Two cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed, etc., 216. Okay. So here we get 2x plus 7, 2x minus 7. It's the easy one of the two. First, second. Change your signs so that stuff cancels in the middle. I could show you guys the stuff canceling with this, with a box. It's just a weird box where it's like you got 3 things going on here. You got 2 things going on here. You could see how like stuff would cancel and you would end up with just x cubed plus 216. I'm not going to do that. I really want to, though, so I'm going to do it. Watch. Check. You can always check. Here's x cubed. Here's -6x squared. Here's 36x. Here's 6x squared. Boom. They're gone. Here's negative 36x. Boom, they're gone. Here's 216. Look at that. It's just like so beautiful. Math is so beautiful. I love math. Okay. All right, so I got x equals negative 7 halves, and x equals positive 7 halves. How did I do that? Set these equations equal to 0, subtract, then divide. Add slash subtract, then divide. Yo, what do we got? Cubes. Cubes. Bam, bam. Bam, bam. First, second. First, first. First, second. Second, second. What times itself 3 times gives us 27? 3. X times x times x is x cubed. 3x is my first one. 512. Oof, I don't even know that. Is that 8? 8 cubed? Use your calculator. Boom. 8. Okay, I call this my first. This is my second. Ready? First, second. First times first. This is where people make mistakes. 3x times 3x is not 3x squared. 3 times 3 and x times x. 9x squared. First times second. 3x times 8. 24 x's. Second times second. 64. If your teacher requires you to fill in the m squared and the n squared, that's what you fill in. I don't for my students. I just want this factored form. Soap, same sign, opposite sign, always positive. Same sign, opposite sign, always positive. What will our solution be? It'll come from this piece. Add 8, divide by 3, x equals 8 thirds. This, you're not going to get any real solutions from that, but in the future we'll find imaginary solutions. Yo, remember? Greatest common factor? We did that work. We divide that 5. Like, there's a 5 here, but you can ignore it. Again, we're talking about squares. X squared, 2x, 3. It's a difference of squares. 3 times 3. Don't worry about this for squares. It's just first, second, first, second. 2x plus 3, 2x minus 3. I think we've figured this one out before. That's going to be for that one. That's going to be that one. Set up the equation and solve. Please don't make mistakes on this. Please don't on your test. Please don't on your test. Go too quickly, and for every single one, you're like, oh, 2/3 is my answer. Because you're trying to memorize something and you're doing it incorrectly. Please don't. Please don't. Please. Just for one, and then you can go from there. Solve. Please don't make mistakes like that. All right? Yo, cubes. Bam. Smaller. Bigger. First. Second. First, first. First, second. Second, second. Okay? Okay. 250. 250. 250. I don't think this is going to work. I think we need to divide out a number. What? All right, well, 128, what can that be divided by? 4? That doesn't help. 3? 2? Oh man, yo, remember at the beginning of the class, beginning of this video, I'm like, oh, factor out a greatest common factor. I thought I didn't see it. I didn't see it. You could divide both of these by two. 2. 125x cubed plus 64. Tricky. Greatest common factors, man. Like it's tough, but it's there. Uh, 125 is 5 cubed. 5 cubed is 125. So 5x cubed is my first. 64 is 4 cubed. 4 is my second. Fill in our gaps. First, second. First times first. Oops, not x cubed. It's just x. Sorry. 5x times 5x times 5x is 125x cubed. Okay. First, second. First times first. 5x times 5x. 25x squared. That's what some teachers will look for right there. First times second. 20x. Second times second. That's 16. That's 16. Soap. Same. Opposite. Always positive. The only solution we'll get is from this one in factored form. Please don't make a mistake on this, guys. Do not think this is easier and then do every single one incorrectly. X is negative 4/5. This needs to be shown or you won't get credit, and we'll use it in the future. Okay? Hope we understand this, guys. Is everything on one side? Did you factor out a greatest common factor? For day 2, for my students, if A's 1, no boxes needed. A's not 1, you got to use the box. Check by distributing. Check using distribution. Distribution is like what originated before factoring. We are backwards distributing, okay? And then squares and cubes, guys, firsts and seconds. Just like pay attention to them. And I really am hoping for really good results on this test, okay? That's it. I will see you out there. Mr. Messner out.